Okay, friends, in this lecture we will study step up, step down chopper, which is also called as a buck boost converter or a regulator. Okay, so what is buck boost converter? Buck boost converter is a converter where you can vary, rather, you can get a buck output, that is a step down output, or you can get a boost output, that is a step up output. Okay, now here we can see there is a switch, inductor, diode. This is a load and capacitor for a constant. This thing also voltage it has been shown. Now the circuit consists of a DC voltage Vs, chopper switch Ch, then inductor L, diode D, capacitor C, and load. The function of L here is to store energy and release it whenever required. Okay, and C will tends to maintain the load voltage constant. Now you can observe from the circuit that the load voltage polarity is opposite to the source voltage polarity, which is very important point. That's why it is also called as a inverting regulator. Okay, because input this source voltage having plus polarity upside, and at load you will get inverted output. Okay, current waveform for the chopper is shown here in this particular diagram. Okay, now when this switch is on, what will happen? The supply will follow the path like this from here through inductor, and it will complete path. Okay, now when it is conducting like this, the current through the inductor will started increasing slowly, and you will reach to the current height. Okay, now during this time energy will be stored in the inductor. And how to find out the energy stored in the inductor? It is nothing but input voltage, okay, multiply by current this I1 plus I2, average of this I1 I2 by 2, that is average of these two, into on period. Are you getting what I'm saying? Average of these two I1 I2 by 2 into on period into input voltage phase, that is the stored energy. Now when switch is off, this switch is off, that time what will happen? This inductor will supply to the load or to the capacitor, okay, to diode. It will complete path like this. Okay, when switch is off, inductor current will tend to decrease. Okay, so what will happen? The polarity of the EMF induced in the inductor L get reversed because it will develop voltage L by dt across it. Now EMF induced in the L forward biases diode D, and as a result inductor stored energy now discharges through the load, diode D, and even in a C. Okay, this is how it will discharge when it is when switch is off. So diode is discharging here. Are you getting? Now this time energy is released, and what will be the energy released? It is now again I1 plus I2 by 2, that is average, into off period into output voltage now. Now not input voltage, because input switch is off, so output voltage. Okay, so if we assume the system lossless system, then we need to balance the energy equation. So what we can see, energy stored is equal to energy released. So if we compare that with the two equations, that is a Vs into I1 I2 by 2 into T on equal to V0 into I1 I2 plus 2 by T off. If we do like this, then we'll get our output voltage V0 equal to minus d upon 1 minus d into Vs. Okay, we will get, because minus sign, because it is inverted out. So V0 equal to minus d upon 1 minus d into Vs. Are you getting? Now if you see it carefully, if we put d equal to 0.5 over here, what will happen? 0.5 means here it will be 0.5, 0.5. Well, means V0 equal to Vs. Okay, now if d is greater than 0 but less than 0.5, then what will happen? Then v0 will be less than vs. Okay, you can check it. If you put d equal to less than, means it should be greater than 0, less than 0.5, if you keep it, then your output voltage will be, output voltage will be less than the input voltage. Okay, and if your D, if your D is greater than zero point 0.5 and less than 1, in that case, it operates as a step up, means your V0 will be greater than Vs. You can put what I am saying, you can put it in this equation. Put here D equal to 0.1. What will happen? 0.9. 0.1 upon 0.9 Vs. Okay, so you will get your v0 will be less than vs, and when your d is greater than 0.5 and less than 1, you will get v0 is greater than vs. Okay, so it can work for a same regulator, it can work as a step up or a step down. Okay, what is Chuk converter? Chuk converter, it is exactly similar, but instead inductor now we have used capacitor to store energy. Here we can see input voltage, this inductor, switch, capacitor, diode, inductor, capacitor. Here LC is a filter here. This LC is a filter and output. So what happens when switch is on, that time what will happen? Through source, through inductor, it will complete path like this. At the same time, capacitor has stored energy in it, so it will discharge through like here diode will be reverse bias through capacitor, through voltage, and through inductor it will complete the path. So this is the operation. Are you getting? When switch is on, when switch is off, that time what will happen? So now inductor and supply will completely supply to capacitor, and through diode it will complete path like this. So it will charge capacitor now, and at the same time the stored energy previously in a capacitor and inductor will discharge like this. Are you getting? This is switch off interval. Here also you can see we will get inverted output. In a Chuck converter also, like a buck boost converter, step up step down means buck boost. Like a buck boost in Chuck also we will get a inverted output. Are you getting? Here we can see. So when switch is on, this is how it is conducting, and capacitor is conducting like this, through capacitor, through load, to inductor, it is like this. Okay, so that time output current is increasing like this. Capacitor voltage through across capacitor is decreasing because capacitor is discharging, and output voltage is increasing. Okay, because capacitor is charging is increases. Now when switch is made off, that time it will conduct like this through diode, and through stored energy in the inductor will be discharges like this. So in that condition, current through L1 will be decreases because inductor is discharging now. At the same time, voltage capacitor is charging, so it is increasing. Output voltage will be decreasing because inductor and capacitor is discharging. But current you will get continuous. Okay, so Chuck converter is also exactly similar like a buck boost converter. Okay, so with this we have covered your buck boost, and Chuck converter, and your second last chapter. Thank you.